Hi, I'm Syed Rahman from Monolithic Solutions, and today I will briefly demonstrate the features of our latest product RFX-4000, which is a fully automated RF test station, ideal for testing depot level SRUs operating at frequencies up to 20 GHz. The feature-rich RFX-4000 provides extensive capability for RF testing, and with the ease of an extremely user-friendly graphical user interface makes RF testing a lot of fun. RFX-4000 integrates various RF instruments to provide capabilities such as frequency domain analysis, time domain analysis, network analysis, can measure noise figure, phase noise, can generate complex signal waveforms, can generate power supplies, DC voltage up to 60 volts, and above all the instruments in the RF80E are accessible to RF ports which are fully switchable, and that allows for a fully automated single-click testing operation. As you can see, RFX-4000 is comprised of 3 system racks. The way we have arranged equipment in the rack is such that we have kept RF equipment closest to the switch matrix to minimize the path loss, and we have put low-frequency equipment such as power supplies, low-frequency oscilloscope, or digital signal generators further apart. This particular rack mostly includes RF sources. This is a vector signal generator that can modulate a carrier up to 20 GHz with pulse modulation, complex waveform generated by built-in arbitrary waveform generator. These are 2 scalar signal generators that can generate clean RF sources up to tones up to 20 GHz with phase noise less than -130 dBc per Hz at 1 GHz with 10 kHz offset. This sums up to 3 RF sources in the system that makes it possible to test an IQ receiver. The RFX-4000 includes 4-channel power meter that can measure RF power up to 20 GHz on each channel. One of the unique features of this ATE is that it includes a noise figure analyzer with built-in smart noise source that make noise figure measurements possible. This rack also includes a low-frequency oscilloscope, which is a good utility for RF testing. The central rack includes the heart of the system, which is RF switch matrix. This switch matrix provides a fully automatic, switchable interface to each of the equipment in the system. The switch provides low-loss RF paths to RF equipments with losses less than 3 dB at 20 GHz. The switch matrix features an interchangeable interface to connect the devices under test, such as, for example, I can connect this loopback device through a sliding interface. Such a sliding interface eliminates the need of manually fastening the RF cables. That makes the RF measurement not only reliable but also easy. In addition, the interface changeable adapter also provides connectivity to each of the equipment in the system that includes power supplies or low frequency signal generators. The EK interface includes 6 RF output ports and 6 input ports. The RF output ports are routed to RF sources such as signal generator and noise source, whereas the input ports are routed to measurement equipment such as oscilloscope, network analyzer, power meters, spectrum analyzer, etc. This rack also includes a vector network analyzer that can perform network analysis at frequencies up to 20 GHz. It can measure S parameters and display Smith charts. This rack also includes a high frequency oscilloscope that can capture time domain signal at frequency up to 2.5 GHz. There are plenty of DC supplies in the RF80E to power the devices under test. That includes 12 volt supplies, 20 volt supplies, as well as 60 volt supplies. All of these supplies have built-in overvoltage and current protection. The third rack includes the main system controller, which runs the software of this test station. This system controller is based on a PXI platform that was chosen to provide a flexibility to add test equipment as per the requirements of the test. At present, This controller is configured with 4 precision digital multimeters, TTL IOs, industrial IOs, low frequency signal generator, and digital switch matrix. This is a 102 channel logic analyzer and pattern generator. That's very useful for digital signal analysis. This rack also includes a high frequency spectrum analyzer that can perform spectrum analysis at frequencies up to 26 GHz. This rack also includes the power distribution of the system. This is a 30 kVA PDU that provides abundant margin for the power requirements of the system. It also provides the power control, which includes system startup and system shutdown for the system. The PDU is responsible to gracefully shutting down the system to eliminate disk errors. It also sequences the shutdown and startup sequence with delays to minimize the abrupt power glitch. The PDU is backed up by an uninterrupted power supply. Software is one of the most critical parts of any automatic test station. RFX-4000 includes a very user-friendly software platform, which includes a powerful API to develop test programs and allows to control or access each feature in the ATE. The API is compatible with National Instruments LabVIEW and TestStand, which are powerful tools to develop test sequences. RFX-4000 also includes a very user-friendly gateway console application. This console application provides a soft control of each and every single feature in the ATE. The console application initializes the system and provides a very user-friendly arrangement to each feature of the system. The console application has built-in test routines that includes phase noise, two-tone and spur measurement for linearity, frequency response, S parameter measurements, noise figure, and this routine can also launch custom developed test programs. The console application provides soft control to all the sources in the system, which includes vector signal generator, scalar signal generators, low frequency signal generator, and power supplies. This application also provides access to all the measurement equipment in the system. That includes network analyzer, spectrum analyzer, noise field analyzer, oscilloscope, low frequency oscilloscope, power meters, and digital multimeters. Console application provides a very user-friendly graphical user interface. Control the switch matrix. Using this interface, the user can very easily connect any port to any instrument by click of a single button. Through the console application, user can also access all the digital features of the system, which includes industrial I/O, TTL I/O, digital switch matrix, logic analyzer, and pattern generator. The routine also performs basic various housekeeping tasks such as calibration and self-test. The routine measures the path loss of the RF switch matrix that can be calibrated. The routine provides access to other system utilities such as temperature monitoring of the racks of the system or alarm conditions. The power distribution, where the current through each phase of the system can be monitored.